Welcome back. Today we are talking about relational databases, why they are matter and how they power countless applications around the world. Okay, first let's start with an introduction, like an intro, small intro to the relational database. A relational database is an organized collection of data stored in tables, something like that, where each table represents a specific entity like customers, users, tweet, following, or products. These tables can be related to each other or um, like they can relate to each other through keys like you can find like or maybe like other things like we have here they are related to each other like username here we have we can add id and use user id as well. So you find like there are stable, and these tables have relationship between them. So next we need to talk about the core concept of relational database. And first we start with tables. Data is arranged in rows, which is records, and columns, which is attributes. For example, like a user table might have a columns for user ID, a name, and email. Next, we have what we call a primary key. Which is the primary key is a unique identifier for each row in a table. For instance, user ID ensures each user is um, un it's basically uniquely identifiable. It's like each user has its own ID. There is other thing we call foreign key, and all of these things it's a pretty important for you guys to understand. So if in your system design interviews, when you have been asked to design the entities of specific of specific attributes in your system, you can do them. You know tables, you know primary keys, you know like foreign keys. Foreign keys it references a primary key in another table, creating a relationship between two tables. For example, user ID in an order table links the order to a specified user. And we have what we call schema. The schema defines the structure of database like a blueprint. It outlines how tables relate to each other and what types of data they store. So this is some concepts. I guess they are pretty important to understand. In your system design interview, you might be asked to design your some entities in your database. So you need to understand the table concept. You need to understand the primary key and the following key, and you need to understand as well the schema. Okay. Next, we want to talk about the ACID property. The ACID property, which is stands for atomicity, consistency, isolation, and durability. We can start first with the atomicity. Atomicity. So, atomicity means that all parts of a transaction succeed or none at all. It's as easy as that. And I will create a video that talks like about what is ACID properties in details. Next, we have consistency. Consistency means that every transaction takes the database from one valid state to another, and once it's changed, like once the data is changed, it will never be rechanged again. Not like that. Not like that. It means basically when the data is changed, it is there forever until it's changed again. Next, we have isolation. Isolation means transactions operate independently without interfering with each other. Next, we have durability. Durability means like once a transaction is committed, it stays committed even after a system crash. Okay, but what are the advantages of relational or SQL databases? The first thing I would say is structured data, like ideal for data that fits well into rows and columns. Um, Second thing is data integrity and reliability, like asset properties ensure trustworthy transactions. Number three, powerful querying with SQL, like structured query language. SQL lets you easily retrieve and manipulate data. For widespread use and support, like relational databases are well established, where a large community, um, plenty of documentation and robust tooling. There are a lot of common relational databases like MySQL, Postgres, SQL Server, and other things. Like there's a lot of them. And in terms of system design interview, I would say that by default you go with SQL or relational database. Only four things when you should choose like a NoSQL database. I would say the first thing is that if we have like a huge amount of data, like let's say that we have like a chat application when we have like billions of messages every day, or your data is not structured, or maybe you and or your data is semi-structured, or also if you don't know if you are not sure of how to structure your data or how to do the schema, so you need more flexibility. If you need your data to be highly available, so you go with no SQL database. So in conclusion, let's make like a wrap up. In conclusion, um, we like that's it for our introduction to relational databases. We covered tables, keys, asset properties, and some common systems. If you found this video useful, like, share, and subscribe, and hit the notification bell so you never miss any video. And see you in future videos.